I'm Mrs. Kiva, and today we'll be learning about rational and irrational numbers. The objective for today's lesson is to be able to differentiate between rational and irrational numbers. First, let's talk about what is an irrational number. A rational number is any number that can be expressed in the form a over b. Remember that a and b must both be integers, and b cannot be 0. Keep in mind throughout the lesson that integers are all positive and negative counting numbers. Let's go over some examples of rational numbers. Generally, when you see a rational number, it's going to be a positive or negative whole number. All fraction and mixed numbers are considered rational numbers, and decimals that terminate or repeat are also considered rational numbers. So 7 is a positive whole number. 0.21 can be written as 21 over 100, which is a fraction. And 869 over 4016 is also a rational number because it is a fraction. So what's an irrational number? An irrational number is any number which cannot be expressed as a fraction a over b, where a and b are both integers and b is not 0. So for example, decimals that never terminate or repeat are considered irrational numbers. Irrational numbers must be represented by a symbol. Example, pi or a square root symbol. If a decimal has a ... at the end, this is a good hint as that it's irrational. So let's start with a little practice. We're going to differentiate between rational and irrational numbers. So you're going to do this on your own. I'll give you a couple minutes to do it. Just take a look at these numbers and determine whether they're rational or irrational. Alright, and now we're going to check our answers. So 0 is rational because it is a positive whole number. 3.1415 repeating is irrational because, like I said before, remember that if a decimal has a ... at the end, it's normally irrational. Negative 2/3 is a rational number because it's two whole numbers. Pi over 4 is irrational because, like I said, irrational numbers generally have a symbol, so automatically when you see the pi symbol, you know it's irrational. Radical 121. Although it is a square root symbol, you need to keep in mind that some perfect squares do come out to be rational numbers. So the square root of 121 is 11, and that is a positive whole number, so that's rational. Now radical 19 does not come out to be a perfect square, so it's an irrational number. Negative 65 is rational because it's a negative whole number. 0.0001 not terminating is irrational because, again, it has and forever going on decimal. And 100 over 62, although it's going to come out to be a mixed number, it is two whole numbers in a fraction form, so it's rational. Alright, here's another little question for you guys. Which of these approximations of pi are irrational? So there's 3.14, 3.1415, pi, 22 over 7, or all of these, or none of these. So I'll give you a second to think about that. Okay, and the correct answer is only pi. All the other ones are terminating decimals or whole number fractions. Pi is the only one that is irrational because it's a symbol. Pi can also be written as 3.1415, and it can go on forever. So keep that in mind too, that there's always going to be a ... at the end, and as I said, that's a hint as to whether or not it's irrational. So now we're going to compare rational and irrational numbers. So I gave 4 examples of comparing different rational and irrational numbers, and you're going to tell me which is greater than the other. Alright, we're going to check our answers. So pi is greater than 3.14. Although they can be said to be around the same number, pi is technically 3.1415 and it goes on forever. So considering that the 3.14 has a 0 in the thousands place, pi itself has a 1 in the thousands place, so it's greater. 17.9613 is less than 17.963 because, as you notice, the thousands place in the one on the left is a 1 and on the right it's a 3. Now number 3 is comparing radical 9 and pi. So as you know, radical 9 is a perfect square and it comes out to be 3. So 3 is definitely less than pi, which is 3.14. The next one is 16 over 4 compared to radical 18. This one can be a little tricky because you might not know what radical 18 is without a calculator. But if you think about it this way, you know that the perfect square below 18 is radical 16, and you know that radical 16 is 4. So radical 18 must be higher than radical 16, so it's greater than 4. So you can compare something a little over 4 compared to 16 over 4, which is 4. So you know that 4 is less than radical 18. So now here's some homework you guys are going to try at home. I gave you a couple examples of some mixed irrational and rational numbers, and you're going to have to list them from least to greatest. So you're going to have to do that by 11:59 p.m. tonight. Just put them in a Word document, order them from least to greatest, and you can email at me at my Stockton email, kievitb@go.stockton.edu. Thank you for watching, and I hope you know a lot more about rational and irrational numbers.